Hey, hello. Welcome to my Math 250 Calculus 1 Project 4. My name is Daniel Acosta, and my student ID is 2254144. Now, let's get this started. So it's going to be kind of simple. I used Canvas for the problem and how I laid out the steps so I could use its special fonts and all that. But for today, we are going to the definition of the chain rule and implicit differentiation. I can't pronounce differentiations, implicit differentiations, and then we're going to go over the problem solution that is provided. And I'm just going to link the the references. So, well, that's not supposed to be there. So, what is the chain rule and implicit differentiation? So, the chain rule, according to Stewart from 2015, allows us to differentiate composite functions by taking the derivative of the outer function, evaluated at the inner function, then multiplied by the derivative of the inner function. Now, an implicit differentiation is used when differentiating equations where y is not explicitly solved in terms of x, requiring the application of the chain rule to differentiate both sides of the equation, which is also from Stewart 2015. So basically, the chain rule is a method for finding the derivative of a function inside of another function by multiplying the derivatives of each. And these are my own words, but and an implicit differentiation is when y is mixed with x in an equation. So you differentiate both sides, treating y as a function of x. Both techniques can help solve more complex derivatives. Now we are going to go over the problem and solution for this project. Now, we are solving for A, which is find the equation of the tangent length to the function fx equals parentheses 6 minus 5x over x squared minus 1 to the power 2 add parentheses 2 comma 16 over 9. So the first step we had to do was identify the point of the function endpoint. So the function is going to be obviously fx equals 6 minus 5x over x squared minus 1 to the power 2. And we're given the point also 2 comma 6 over 16 over 9. Now we need to find the derivative of the function. So let's ux minus 6 minus 5x over x squared minus 1. Then fx minus ux squared. And we got it to differentiate fx minus ux squared using the chain rule, which is fx minus 2u parentheses x times u comma or quote x. So we use the quotient rule to find u, which is ux minus 5x squared minus 12x plus 5 over x squared minus 1 in parentheses square. Now the third step is to evaluate the derivative of x minus 2. First, calculate u2, which equals to, or subtract by negative 1 over 3 and u2, which is negative 1 over 9. Then calculate. So f2 minus 2 times negative 4 over 3 in parentheses times 1 over 9 in parentheses minus negative a over 27. So the slope of the tangent line is m minus negative a over 27. Now, the fourth step is to use the point slope form of a line. The equation of the tangent line is y minus y1 minus m parentheses x minus x1 parentheses and parentheses where x parentheses x1 comma y1 and parentheses minus 2 parentheses 2 16 comma 16 for 9 and m minus negative 8 over 27. Now substituting these values, we could get y minus 16 over 9 minus negative 8 over 27 in parentheses x minus 2. Now the last step is just simplifying the equation. So it's to distribute and simplify. And we'll get y minus 16 over 9 minus negative 8 over 27x plus 16 over 27. And we add 16 over 9 minus 48 over 27 to both sides. So y minus negative 8 over 27 x plus 64 over 27, which would eventually give us the answer over here and over here, excuse me, y equals 64 over 27 minus 8x over 27. Now, let's get a part B of the equation. So use implicit integration to find dy dx and d squared y over dx squared for the function 2x squared plus y squared equal 4. So step 1 is find dy over dx. Start with the equation 2x squared plus y squared equals negative equals 4. Differentiate both sides with respect to x, which is 4x plus 2y dy over dx minus 0. Now we just solve it for dy over dx, which will get us negative 2x over y. Step 2, it's a find, which is the answer, by the way. And step 2 is to find d square y over dx square. So differentiate dy over dx equals to negative 2r over y using the quotient rule, which will equal us to y parentheses negative 2 minus parentheses 2x dy over dx over y squared. Now substitute dy over dx equals to negative 2x over y into expression d squared y over dx squared, which equals to negative 2y plus 4x squared over y squared. Now all we have to do is simplify the result, which gives us the answer right here as well. Just d squared y over dx squared equals to negative 2y squared plus 4x squared over y3, which is, let me recorrect what I said earlier for the other answer, which is step 1 from here to here, is dy over dx equals negative 2x over y. I didn't see the subtraction sign. Now we are just going to go for the references, which is from Stewart J. 2015, Calculus, Early Transitionals, 8th edition, Cengage Learning. And thank you for the presentation. And I shall link the video after this recording. Thank you very much.